Hi everyone, welcome back to the channel. We will be starting on the next topics. We have already covered chapter 1, which are these topics that we already covered, and today we will be working on what are constant, what is shadowing, data types, and numeric operations. So let us just open our VS Code. You can start from the existing project that you previously created, or you can create a new project. Regardless, to open folder, lower. Regardless, we will be touching on this basic concepts. Out of this, shadowing might be something, it won't be new to you, but it will be interesting because the terminology is different here. Apart from that, you must have used this thing in other languages also, so this is something critical to learn. But apart from that, constants are same regardless of the language that you use. Constants are constants. That means you use const keyword, and using this const keyword you will, let's see, using const keyword you will define a variable. Now constants are slightly different than variable. They are also used to hold the value, but the value will remain constant across the life cycle of this whole program or software. So for example, the value of pi, right? Now we know the value of pi is 3.14, and we will assign that value. Now why I'm getting error, missing type for const. Okay, so I have to define the type also, so I can define f64. Now what? Yeah, it is working now, no issues. So I have a pi constant, and the type is also defined. Now how is constant different from variable? Now I can define a variable, and I can define a variable like, let's see, let pi value equals to 22/7, if I'm not wrong. So you can see that I have this value, right, and I'm defining it like this. Now at the time of compilation, or at the time of the machine, when it will try to calculate this value, it will take some time or some computation, right, to calculate this value. Now we already know this value, so why waste our machine computation power? Instead we can just define it as a constant, and before the compilation also we can define the particular type of it, so that compiler knows that how much memory to allocate it in advance, and we are saved the computation power. One of the main idea of constant is that it will not be changed across the across your application lifecycle. And another thing to keep in mind, that in Rust we often, it's not hard and fast rule, but oftentimes when you're working in a Rust program, right, you will be the naming convention of a constant will always include uppercase letters. So I can have a Rust pi value, and it will be assigned like this instead of const pi. It's not like a hard and fast value, but a rule, but it is followed across as a standard. And you will often see, if you review other people's code, right, then you will often see the constant value are defined with this the naming convention is in uppercase only. So that is something to keep in mind. So I think with this we have covered constant. It's not a difficult concept, but and pretty basic, but often useful. So we will mark this as done. Now what is shadowing? Shadowing is a interesting concept. So for this to understand, right, you have to understand the concept of life cycle. Life cycle of a variable. Now a variable is only in till the time it is within the particular scope, right? So this is a scope. Now scope can be anything that is between this curly braces. So I can define a new function test, and it is within this curly braces I can define a new variable. It can be the same name, or so let me also assign the same name to it, and let me assign the same value also. Sorry, not this one, same value also. And I can, yeah, that's it. Now I can use the same thing here also, so I can just call it here test, and you can see that I'm not getting apart from this one, I'm not getting any error for it, even though we are using the same variable. But these two are totally different entities because they lies in a different scope. Now the life cycle of this particular variable, let it be age underscore test. The life cycle of this particular variable only exists till the time it is within this particular function. The moment this function goes out of that execution, right, it will cease to exist. Same goes for this age variable also. Till the time the main function is running, this variable will exist, otherwise it will cease to exist. Now to test it out, what we can do here, I can assign a new variable inside this function, inside this curly braces. So let's just define it age equal to 35, println my age age. So you can see I'm not getting any errors, even though I'm getting this 35 error. Value assigned to age is never read, maybe it was overwritten. Yeah, that is fine, nothing to worry about that. So let's try to execute it. So cargo run, it will run the program, and you can see that previously I've defined this variable here 35, it is executing first. So it is saying that my age is 35, and after that for the same variable I'm getting age 25, even though the name is same, but they both are in different scope. And this variable, you can see that this variable is not mutable, and this variable was mutable, so I was able to reassign it. If I try to assign this variable value, I will get a error because I will get an error because this variable is not mutable. So within this particular scope, this variable is different, and that is what we call shadowing. So I can shadow an existing variable by defining a new scope. So even though the variable does exist, when this scope ends, right, I can still use that existing variable, and there's no issue with that. But till the time this scope exists, I can create a new variable with the same name, and the idea is that it will be a new variable. It is not a mutability thing, it is a shadowing thing. Shadowing is different than mutability. You might be confused with it because technically we are just really assigning the value, but with mutable there's one quite a critical difference, that you can't mutate the variable type. So for example, if I try to assign a string to it, or string literal to it, I will get an error. Why? Because mismatch type expected integer found string. So that is because I have assigned this variable initially. Also the compiler has inferred it as i32, and when I reassign the value of that variable, right, I can only reassign the value, not the type of that variable that was initially the compiler defined. So for example, initially when the variable was declared, right, the compiler said that okay, I will give it a memory space that is equivalent for i32. It could be 4 bytes. I'm not sure it is 4 bits or 4 bytes. I'm not completely sure about that, but just for example's sake we will consider it. Now I can try to assign another value to this, but if that is string, right, and string might require 2 bytes or so 2 bits. So this memory allocation is different than this memory allocation. It's not like I can't convert this to string, so I can technically convert it to string, but that does not I mean this is already string, sorry. I can technically convert this to int, but the memory allocation that was assigned previously to this, right, is different than this one. So this only works if I'm creating a new mapping to the memory. So if I create a new scope, and in this new scope I will define a new variable. It could be the same name, doesn't really matter. If I'm using the same name, the concept of shadowing comes in play. So I can assign it here and it will create a new memory space for it. So with mutable you can't mutate the variable type, because end of the day the variable is still the same, the memory mapping is still same. For shadowing you can mutate the value and the variable type, because it creates a new memory mapping. Okay, yeah, it creates a new memory mapping. So this is the only difference between mutable and shadowing, and shadowing is used quite a bit in Rust. Oftentimes you will see that you might be writing a loop and like for example, if I have to give an example for it, let a is right, so let mute I equals to println I, not I, sorry, println I, and let's println age. Let's see how that works. What I'm getting error, doesn't implement it. Yep, it is considering it a function. Maybe this is something I should keep it for next video, because this is something, it is not advanced, but we can tackle this later on. But this is a function. This is also some quite a bit is used in your Rust programming, and there you will see the shadowing part really come into the play. So I hope I was able to make the shadowing concept clear. Data types. So next part will be data types. Now data types, it is same across all the languages. I haven't seen any language which makes it a different set of data types. Generally it is same across all the languages. You will have scalar and compound time. Scalar will be more of a primitive type data types, which generally includes your integer, floating, bool, and I think only these things for primitive types. Integers are mainly your numbers, whole numbers, or it could be euro or negative numbers. Anything that is without decimal is an integer. Floating is your decimal point, so you will have F32, F64. Now this 32 signifies your architecture. So you must have seen your CPU architecture, which might range from your 32-bit or your 64-bit. So F32 is same as F64. It's just the F64 has more precision. When you talk about precision, right, you will mainly be talking about the concept on how many number of zeros you can signify after the decimal. So I can have multiple zeros. F64 has more precision. I don't remember how much it is, but it is more than F32. And in general programming, you rarely requires it. But of course, when you're creating a real world application, the number might be a huge amount. So F64 is the one that you should opt for. By default also, I think it creates F64 only. Let's see. Yeah, by default also it picks F64 only. And bool is your true, false. True and false. It is in a small case, so that is something you have to take care of. But apart from that, it is same, true and false. You must have seen bools in conditional operators. So anything if you're comparing one thing to other, the result will be in either true or false. So that's where bool comes in play. The below table that you're seeing here, right, and you can also see this thing over this particular chapter in Rust programming, which contains data types, and it will walk you through in depth about all of this thing, but I will just try to cover it, the overview of it. So for primitive type, you can see this 8-bit signed and unsigned. Signed and unsigned is not that different. It's just as the name suggests, signed means you will have signed values which will range from negative to positive, and unsigned means you will have the value in positive only. This might not make sense until unless you think from a computer perspective, because at that time you will have a extra digit which actually signifies this symbol, negative and positive. For unsigned, that extra digit is not there, so you will have more set of digits that you can cover in only in positive side. So for example, if I am picking 8-bit, right, so if you want to calculate it, you can calculate on the basis of like 2 to the power 2 to the power 8 minus 1. So 2 to the power 8. Now I can calculate it, but we have Google, why bother, right? So 256. So 256, that is the exact value. Now 256 is for only positive part. So if I go from 0 to 256, so that will be the range for unsigned digit, and you can assign it by giving I8. And for signed digit, which is I8, U8, and for signed one, it will range from minus 127 to plus 127. This is for signed. You can give it U8 and you can give it I8. Of course, when you're programming, these things does not come in play until unless you are working on optimizing your code from computer perspective. So for example, you must have created a program which might be using the memory in certain way, and you might want to reduce the memory computation, or maybe might want to reduce the uh, compute power that you are requiring. At that time you will be using these things in particular. Currently not required. One more thing, there's one more type, U size. U size is it's something different. It's kind of same. It's more of a whole number thing, but it's used to denote your array, not array, but the index of array. So for example, if I'm defining an array. Before I jump to array, let me also cover this compound type of array. So in compound type we have multiple data structure. They are built to collect, or not collect, collect, technically collect or group the primitive types. So compound type can be your tuples, it could be your array. Mainly these are the main compound types. Oftentimes you will be using it, you must have heard also about it. So array is simple, it will be in this brackets, and sorry, tuple will be in this brackets, and array will be in square brackets. If you want to see example, it should be here. Yeah, this is a tuple. So tuple is slightly different. It contains your, like, it is a heterogeneous collection of data. So you can see I can define a I32, F64 and U8. So if we walk through it one by one, I32 means it is a signed integer with 32 bit, so that is I32. F64, it is a floating point with 64 bit, and 64 bit. And U8 means it is a unsigned integer with 8 bit, and you already know this range of it, right? It is from 0 to 256, so the maximum value it can hold is 256. So we will be defining that 500 6.41. I mean, you don't need to define it. Ultimately your compiler will be able to infer it, like for example it is able to infer it, but it is good idea to define it, because you can see here that for this part, why I'm getting error. Okay, I'm getting error because of this. For this part, for the one, it is inferring as I32, even though we are not using it as I32, we are using it as unsigned 8-bit one, correct? Unsigned 8-bit. I can also define it here. So if I want to explicitly signify it that no, this word, not word, it won't be a word, right? It would be a character only. This particular number or character, if that I'm using, is I will be using it of this type. I can explicitly define by first writing this number, and then after that type of it. So you can see it is already updated here. So this is also one of the ways to do it, and we can try to print it. Now I will get this error. This is something we will be covering it later, but for now, this is one of the when you're getting a function, especially, or maybe a particular class. If I have to give an example, a particular class. So at that time, you might want to specify how do you want to display it. Maybe you want to, when you want to print it, you want to display it in a certain manner. Now, if you haven't defined that, you can use this particular format. So I can just simply give colon here and question mark. It technically prints in debug mode. So if I run cargo run, I can see that I'm getting this output. Not sure what this is, but either way I'm getting this output. So yeah, this is tuple. It is a heterogeneous collection or grouping of primitive data types. Of course, when I say it is only primitive data types, but it can be a collection inside collection. So compound type inside a compound type. Nothing is restricting you. I mean, we can try it. Let's see. So you can see it here. In this tuple, I've added one more tuple, and in that tuple, I've defined a string literal and an i32 variable. I don't want it i32. I want it i64. Let's give it i64. So yeah, i64. So you can add compound inside a compound also. That is a liberty that you have. But mainly, regardless, a compound type is, on a technical level, it is still a collection of primitive data types or your scalar data types. Then you have array. So array is stack, the same as the type we have seen for rather the heap. For example, if you were using the name of the month's program. So this is how array is created. It is different than your tuple. So like I said, tuple is heterogeneous, array is homogeneous. So I can define it as i32. That means I will be having the type as i32, and I will be having 5 particular items of i32. I can define it here 1 2 3 4 5, and that matches. Even if I don't define it here, it will be able to infer it, like here. Same thing, we will try to print it out. First we will try with this, and it should not ideally print. You can see it is giving error. So I can print it like this, and yeah, it is working 1 2 3 4 5. But or we can also try to give a heterogeneous value. Let's see, string. Now this is giving error. If we read about it, mismatch type, expected integer, found a string literal. So array only allows homogeneous data. So let me just write it down. Homogeneous data. Homogeneous, yeah, might be wrong spelling, but I hope I'm able to convey the meaning to you. So heterogeneous and homogeneous. So yeah, that is there. So with this we have covered scalar and compound type. I think scalar I missed char also. So char is there. It is quite similar. It's a single bit character, so I can just specify it within single quotes. A char could be anything. It could be emoji also. or it could be an @ symbol, doesn't really matter. And we will try to print it out, and you can see it is able to infer char. Yeah, it is working. So yeah, with this we have covered scalar and compound type. In scalar and compound type, of course, integer, floating, bool, char, it is quite basic. It's just that the difference between tuple and array should be known, and how and where you should be using it based on your requirement. So if you want to declare certain set of similar data, which might be maybe a month that are there in the year, January, February, March. So if you're denoting as a string, right, so you will be assigning it an array, but maybe you want to annotate, or you want to store the data of birth date with the day, month and year. Now day is different, month is different, year might also be same because it is your string only. So date might be 27, so that might be an I32 value. Month might be your January, so it might be a string value, and year might be your, it could be as number also. I mean, nothing stopping you with that. You can give it I64 or I32, but you get the idea, right? You can store heterogeneous data in tuple. So with this we have covered data types part also. Lastly, numeric operation. For numeric operation, for simplicity of the things, I will be defining two variables which could be of I32 type, and we'll be assigning values to them. One will be 2 and another will be 5, because it is easier to calculate that way. So the first operator will be println, not print, println 2 star 5. So star stands for your multiplication. Great. For multiplication, so that is star. If I want to add that, then I will give a plus symbol, which will be meaning addition. If I want to subtract it, I can specify minus symbol, and if I want to divide it, I can specify slash. Let me also update this one, minus slash. And finally we have modulo symbol or percentile, however you want to read it, but technically it is a modulo symbol, and this is used for getting the remainder. Is it for remainder? Yeah, it is for remainder, if I'm not wrong. So we will try to run this program, and let's see if it is really for remainder only. So first is 2 into 5, 10. This is correct. Second is 2 plus 5, 7. This is also correct. 2 minus 5, negative. Correct. 2 slash 5, 0. Why this might be 0? Even though you must be expecting the answer to be in floating type or decimals. Since the values are in I32, it will round off the value also to I32. And lastly, 2 percentile 5. So if I 2 percentile 5, So if I divide, what I'm doing here, if I divide 5, no, if I divide 2, so this means if I dividing 2, divide 2 by 5, so 5 zeros are, I mean 5, technically there's nothing, nothing can divide 2 if the number is bigger, right? So the answer will be 0 only, so that will be your quotient. So that will be your quotient, and 2 will be your remainder. So percentile is, or modulo is used for getting the remainder. One more interesting thing that I want to cover is overflow. We will just see overflow here. So you can see I'm using I32. Let's convert it to unsigned digit. And let's again try to run it. Now. I mean, these all are fine. This one that is there. Now, even though it is given the correct answer, I mean, I was expecting a random value, but it has given a correct answer. But technically, unsigned digit does not have any negative value, so this might have worked correctly on your machine, but it could give a totally different answer on other machine. So Rust is not like JVM, or it's not like Java. So Java has a concept of JVM, so it's more like instead of running code or building a code and running on different machines which will give different outputs, because every machine has a different way of handling memory and compute. Java is this thing. It's quite a genius thing to do, but it has its own issues. It ships JVM. So what it does, it creates a virtual machine. So the code that you're writing, it will be running on that particular virtual machine, and regardless of wherever you run it, right, the virtual machine will remain static only. So that way it ensures that you write a code on your computer, it will be able to run on other computers also. Rust does not do that. So it also like C only, where you're writing a code on this computer. Now in this computer, even though the way it has handled overflow, it has given the exact value, but maybe in another computer this value might not have worked. It might have given a random value, like for example, so let's say you have a variable of type u8 that can hold value between 0 and 255. If you try to change the variable value outside that range, integer overflow will occur, which can result in one of the two behaviors. When you are compiling in debug mode, Rust include a check for integer overflow that causes your program to panic at runtime. If this behavior occurs, Rust use the term panicking where program exit with error. When you are compiling in release mode, Rust does not include checks for integer overflow, which causes panic. Instead, if overflow occurs, Rust performs two complement wrapping. In short, values greater than maximum value the type can hold wrap around the maximum. So in this case, I think it has done wrapping. So we will try to see it. If I can make me run it in debug mode. Let's see. Cargo verbose list, explain, quite locked offline, jet flag, build, check, clean. Let's see. Let's search it. Cargo running default cargo compiler with using development profile. Complete debug symbol included. Doesn't explicitly opt out of debug like using. Or we can try to run this particular program also. Hello world. It's working. I mean, it is not relevant, but still I want to show it to you guys. Cargo clean, and let's again cd target. Okay, SOC terminal. Hello world. Okay, so if I again build it, finished, unused variable num2. Array, wait a minute, we are not using the variables. Wait a minute, then how can I show you? My bad. It was I mean, if we were using the variables, it should not have caused the issue. I mean, it is fine. We all make mistakes. I mean, this one is pretty stupid mistake, but oftentimes in programming you will make a stupid mistake, and believe me, you will spend hours on troubleshooting, and you will get to realize that it would be the minute of the mistakes that cause the issue. Maybe a missing semicolon, or maybe a missing variable name. So let's try to run it now. Attempt to compute which follows. So this panicked, and this is how panic error message you will see in cargo, and you can see it has quite descriptively told that what the issue was, and you can of course fix it as you want it, but technically there's no way out of it. You are trying to compute a value that does not exist in this particular range that this particular type offers, and of course it will overflow. Either you can try to put it in wrapping. So these are some functions which can put it in a wrapping mode, so it will try to not let it overflow, or more like for example, if I was hitting a value that might be more than 256, it will again go back to 0. It will start from there. So that is how wrapping technically works. So I hope I was able to make this overflow concept clear. And this is one of the beautiful things about Rust. Generally, if other programming language, you might not know that this overflow things only when the program actually crashes, then you will get to know that something overflowed. But in Rust, it precisely tells you like where it is getting where it is breaking. One more thing I wanted to show you lastly before we close this video or close this tutorial. Let's create a array. So for array, I will create a square bracket, then I will define type i32. I think i32 sounds good. Then I will give a semicolon, then I will define 5 should be a good amount of number of items that I want to keep in the array. 1 2 3 4 5. And now if I want to access the value, the way to access the value in array is just 0, and like always we have to give it so the value start from 0. So this 1 actually will be, the index of it will be 0, 2 will be 0, 3 will be 0, 4 will be 5, and like previously we talked about u size, right? So if we try to assign a value I equals to 0, this value is I32. If I try to assign this value here, this value changed to u size. So in this particular thing, the only value that it will take is u size only. If you are not defining it as u size, then you have to typecast it. So I can, like for example, this is giving me error here, and I can typecast it as was giving this as u size. So this is typecasting it. Of course we don't need to do this stuff, but it is good to know. So I will give it 0 and try to run cargo run, and see, it is able to access this particular value. Now for example, if I give a value that might not be there in the index, so how it should behave? So let's run cargo run, and it is panicking. This is interesting because a lot of programming languages will let you access this particular memory location also, and oftentimes it will all those CVs that you see, right, for Microsoft Windows update and all that, there oftentimes you will see the memory leak or unauthorized memory access. All those things are only these things only. I mean, it is same issue only, of course on larger scale, but ideally it will be on the same issue only. So you are trying to access a memory location even though you don't have the access to it, or more like it is not there. So when the compiler is defining it, it might be defining it in a particular stack, that okay, 1 2 3 4 5, I have allocated this certain set of memory to it. That does not mean that your program can't access other memory slots that are available with the computer or for the computer. Your program can access it, but rest is making ensure that you can only access what is you have declared, not something that you haven't declared. And it has enforced that exception handling, at least on its own level. It is panicking, otherwise you would have gotten the value out of it if you have tried it in different language. Most probably in C, if you have tried it, you must have gotten a value for it for sure. So this is interesting, and you can also read more about it here. This is one of the memory safety principle in action, and this kind of check is not usually done, and when you provide an incorrect index, invalid memory can be accessed. So Rust protects you against this kind of error. And this thing, Rust memory safety principles, this is one of the important features which make Rust so good, because you have C, which is fast, it is super fast, and it is the most simplest language that a programmer can learn to converse with the computer. In fact, all of your LLM, machine learning algorithms, even though you must have heard that Python is the one that you use to work with LLMs and machine learning algorithms. It might be Python there for it acts as a remote, so it acts as a front end. You can access it. You can using Python. You can access it to create your LLM, create your machine learning algorithms. But under the hood, it is C and C++ only, because Python does not have that speed to run all of this things on concurrent threads. So under the hood, it is C only, and with C, it is a low-level language, and it does not have that memory safety thing. So oftentimes it will try to access or try to give weird outputs if you try to access something that it should not be accessing. Rust does not let you do it. It handles those things. Of course, you can add your own error handling later on, but on a quite a basic level, this is how Rust handles it. So yeah, I think we covered quite a bit here, and I hope that I was able to help you with learning these concepts, and we will wrap this up today and on to the next one. Thank you guys. Thank you. Like and subscribe. Bye.